So now we know that how, with a simple one lens, we know how to make an image, which is great. And now move one step further about understanding this traditional microscope, which is composed of a single lens over here. But those images will form somewhere here in the image plane, and we have to use our eye. Our eye has a simple one lens, so that you remember when you look at under the microscope, you see something like very big. So let's use our geometric optics to understand that phenomenon. So, and also I will discuss about real and virtual images of a light microscope. So this is a little complicated, so bear with me. So let's assume that we have one lens microscope. So one lens, we just made a geometric optics to make a form an image. So we need only two rays. This lens has f0 as a focal length, and object ray parallel has to pass through the f0, and then another ray which pass through the center will not be disturbed because of this symmetry, and it goes, and you will find out there is an image form because of this convergence of the light. So now, so far so good. But now we have our eyeball. Okay. Let's assume let's assume this is an eyepiece over here. So eyepiece have this focal length, but the trick here is the image should be formed within smaller than this f of the eye piece, and that's the point. Then why this is important? As I described from the lens equation previously, if the object location to this lens is shorter than the focus or focal length of the lens, what happens is the rays coming out of this object, okay, will not focus on this space because they are eventually diverging. But we have to always think that how we perceive outside of the world is based on the direction of the ray, because they have to focus down onto our retina, or our retina should, we should recognize where comes this ray. If we have only these rays available, we are considering the rays coming like this far point where they were supposed to have a focus. So this is what we perceive. Remember, this is very similar to when we discuss about mirage, which is, in fact, it's not true that oasis, palm tree, is not underneath the ground. But we can perceive that depending on how rays coming into our eye. This is exactly the same. Let's apply geometry of this one more time. So the parallel ray will pass through this f of focal length, f sub e, okay? And then the other rays like bend. The problem is this distance is shorter than this. So that means is the rays will not converge in this space. So here comes our eyeball, and our eyeball will perceive these rays to form an image over here. And we consider the object through our lens exists over here. Isn't it amazing? So that's how we actually see under the microscope. And here I want to discuss with you. Think about, let's put a film and see if there exists an image. So if we put a film over here, of course, the actual light will focus down, so you will form an image from here. So that's real, okay? However, we perceive this one as we perceive there exists this object somewhere there. But what if we put a film over here? What can happen? In fact, these lines are dotted line, which doesn't exist. It only exists after this eyepiece lens. This ray exists, but the other part doesn't exist. We just perceive it. So even if you put a curtain or a film over here, you will not get the image because this image is a virtual. So I want to explain here as if this image can be seen on a screen placed in the image plane. So that's a real image we call. But after the eyepiece and to our eye, you cannot observe a viewing screen or record on a film over here. That is called a virtual image. So hopefully this makes sense to you. And so viewing an image in a microscope is, in fact, what about our retina? Yeah, this is a screen. The rays will actually focus down. So it's a real image. So viewing image is a real image forming on our retina, but it's perceived as a virtual image. It looks to us that there's a like flipped and big object exists over here. And that height difference is, of course, in the end, we call so-called magnification. So, and this one really shows that the outside of the world as what we see may not be always real. It could be virtual, like virtual reality.